Hello everyone, welcome to my channel. In this video, I'm going to discuss the example for Poisson distribution, where we know that it is a discrete situation, so means that the sign is very important. The random variable y is Poissonally distributed with mean 1.0. Find the properties that using the Poisson formula and the table. So here we have the formula for the Poisson distribution, where we have e to the power of negative lambda to the power of r over r factorial. So kindly refers to A, where we have y is equals to 7. So probability is that y is equals to 7 is equals to e to the power of negative 1. Lambda represent the means. Then we have 1 to the power of 7 because r is equals to 7 over 7 factorial. So by using the calculator, and we have the value 0.0001. That will be the probabilities that y is equals to 7. By using the table, probabilities that y is equals to 7, as we all know, the Poisson distribution table is a greater than table. So the formula would be probabilities that y is greater than equals to 7 minus y is greater than equals to 8. So kindly refers to the table, and we have the mean value 1, and the y value will be equals to 7 and 8. So here we have the table of Poisson probability. So kindly refers to the lambda, or we can say the mean or the expected value is equals to 1.0. So here we have the 1.0. And then we have the r, which is 7 and 8. So in here we have the r is 7, so the value is 0.0001. And as we can see that from the table, there is no value for r is equals to 8. So it means that r is equals to 8 is equals to 0. So meaning that in here we have 0.0001 minus with the 0. So the probabilities that y is equals to 7 will be equals to 0.0001. Kindly refers to B, where we have the probabilities that y is less than equals to 5. So in here means that we have to add on y is equals to 0 plus probabilities that y is equals to 1 plus probabilities that y is equals to 2 plus y is equals to 3 plus y is equals to 4, and finally y is equals to 5. So substitute the formula, where we have e to the power of negative 1 bracket lambda, we have 1 to the power of 0 over 0 factorial plus e to the power of negative 1, where we have 1 to the power of 1 over 1 factorial plus we have e to the power of negative 1 to the power of 2 over 2 factorial plus e to the power of negative 1 to the power of 3 over 3 factorial plus e to the power of negative 1 to the power of 4 over 4 factorial, and finally we have e to the power of negative 1 to the power of 5 over 5 factorial. So by using the calculator, and we calculate the value, if we total up the situation, the probabilities that y is less than equals to 5 will be equals to 0.999 and 4. That will be the situation for using the Poisson formula. So by using the table, where we have probabilities that y is less than equals to 5. So as we all know, the table is a greater than table. So what we have to do is to modify the situation. 1 minus probabilities that y is greater than equals to 6, because 5 is included. Kindly refers to the table with the mean value 1.0, and the value for y is equals to 6. So here we have the table of Poisson probability with the lambda 1.0 and the value of y is equals to 6. So the value will be 0.0006. So where we have 1 minus 0.0006. So the probabilities that y is less than equals to 5 will be equals to 0.9994. So that will be the answer for B. Next refers to C, where we have the probabilities that y is greater equals to 3. As we all know, we are using the Poisson distribution table, so it means that it is a greater than table. So kindly refers to the table, where we have the mean is equals to 1.0 and the R is equals to 3. So as we can see, the lambda is 1.0 and we are looking for R is equals to 3. So the value will be 0.0803. So here we have the answer, 0.0803. So now I'm going to use the Poisson formula. So regarding the situation, it is better for us to find the less than instead of using the greater than. So my suggestion is to modify the situation. 1 minus probabilities that y is less than equals to 2. So meaning that we have to find the value y equals to 0, y equals to 1 and y equals to 2. So 1 minus bracket, where we have e to the power of negative 1, 1 to the power of 0 over 0 factorial, plus e to the power of negative 1 multiply with 1 to the power of 1 over 1 factorial, plus e to the power of negative 1, 1 to the power of 2 over 2 factorial. So kindly determine the value. So where we have 1 minus bracket 0. So if we sum out the situation, and we will have 0.0803. So that will be the answer for C. Next, discuss the D, where we have the probabilities that y is greater than 1 and less than equals to 4. So my suggestion is to modify the situation because sign is very important. Where we have the probabilities that y is greater and equals to 2, less than equals to 4. So by using the Poisson formula, we are interested in y is equals to 2 plus y is equals to 3 and y is equals to 4. Kindly substitute the formula. Plus with e to the power negative 1, 1 to the power of 3 over 3 factorial, plus e to the power negative 1, 1 to the power of 4 over 4 factorial. And we will have the answer. If we sum up the situation, and we will have probabilities that y greater than 1 less than equals to 4 will be equals to 0.2606. Kindly refers to D, where we have to use the table. So previously we already have probabilities of y is greater than equals to 2 and less than equals to 4. By using the table, we are using the greater than table. So meaning that we have to create a formula. Probabilities that y is greater equals to 2 minus the probabilities that y is greater equals to 5, because 4 is included. By referring to the table, we are interested in looking for the 2, where we have 0.2642, and then the value 5, where we have 0.0037. So here we have 0.2642 minus 0.0037. Probabilities that y is greater than 1 and less than equals to 4 will be equals to 0.2605. So here we are, and thanks for watching.